All right, hello everyone. My name is Vlad. I'm one of your week TAs for your MATLAB course for the EnviroGeo and the Architectural Engineers. And today I'm just going to cover just like a basic review of what sort of content might be covered on your first quiz. So today I'm just sort of gonna go over what to expect over your quiz, and I'll give you a few tips and tricks before you actually start your quiz. And then I'll go over some of the important content and some of the homework and tutorial questions that will be very helpful if you deeply study those. Questions. Okay, so I'm going to start off with the introduction. I'm going to give you guys some helpful tips, when you're actually doing your quiz, because you guys are so used to just constantly submitting until you get your answers right. And while that is a good way to sort of learn and try to debug things, it's better to try to learn how to debug things through your actual MATLAB editor. And today I'll sort of be going over that so you guys can get a head start on your quiz. So I guess my first step I've already mentioned is to always have your computer, always have a MATLAB open on your computer. And when a question, let me just open up a question really quick. When a question, such as this one, gives you examples of like dimensions or like dimensional arrays, it's a good idea to always check your command window. Oh, sorry, I don't have a good example, but let's say you try to create a, what is this? We'll call it X. Let's say like your question asks you to make an X by N vector. It's always a good idea to check your command window to see if your arrays have those dimensions. And while it does sound pretty obvious, believe me, the chances of you just like not getting your answer right for the first try is pretty high if you don't learn how to double check things. So that's one tip I have. And when you're actually writing your quiz, so I'm gonna just go back to this window. When you're writing your quiz, always make sure to keep a note of what your code does, because part marks are distributed easier if you do so. So just to give you an example, let's say I have a chunk of code here. I'm just going to give some gibberish, but placeholder text just so you guys get the idea. Let's say that these are givens. You might want to just give it a %, and then maybe 2 dashes, and then say that these are my givens. And then my code actually starts here. Sorry, I might cut that out, or I might not. Who knows? We'll see. And then this part will tell you what this part of the code. You'll sort of give a description of what that does. So if that replaces elements within an array, so then you might just want to say, okay, well, this section replaces element X with Y. Just give like a quick description of like what chunks of your code do. It's not necessary, but keep in mind that because like you won't get these questions right in your first try, like we do have to look over your quizzes and we do have to read your code, and it does help a lot when you do give those like helpful notes. Okay, let's see what my next tip is. And my last tip is always double check and reread questions. So today actually I just got off, or not just got off, well, I had a call at around 4, not that you guys care, but with the student class reps, and some of you guys have complained about some of the clarity on some of the questions, and I hear you out. I do think that if questions aren't clear and you start having to guess, it is completely unfair, especially on a quiz when you only get one submission. So we will be there during the quiz. If you guys have any questions, if you don't understand anything, But do keep in mind that like we are triple checking, quadruple checking, and we're getting some of our online assistants to double check our grammar and making sure that everything makes sense. All right, so now that I got the introduction out of the way, by the way, this is posted under GitHub. So if you go to AEGO121 and then you hit tutorial and then QUIZ01MD, you will be directed to this sort of instructions on how to take a quiz for our MATLAB course. Okay, content-wise, let's get to that. So since Noreen, your instructor, and I have been creating these questions, we sort of had to have like a good idea of what what practice we should give you guys for the quiz, because like we know these questions off by heart. So I just compiled a list of questions that you guys might want to do when you study for this quiz. I don't have a note of I don't have a note of the questions, but I will leave that in the description, and I'll even put timestamps of some of the questions that I might do, or some of the questions that I will be doing throughout the course. So let's open up MATLAB Grader, and the first question that I want to cover is in your homework 2, matrix manipulation, the one with 2 stars. So let's go to that really quick. All right, potato computer. Okay, so I'm gonna just flat out not give you guys the answer, but I want to help you guys as much as I can for this quiz. Just some of these questions are really similar, and this question is closely related to one of your questions that you will definitely do in your quiz. But let's pretend that I am taking this quiz and I'm trying to make sure that all my answers are right for the first time that I submit them. So I have my MATLAB editor open. Let's see if I can put this halfway, so that way we can see the questions and we can sort of work as we go. Okay, so matrix operation, 2 stars. If you guys have already done this question, that's cool, but you know, there are quite a chunk of you who still haven't done it, which is this gray area right here. So it would be a good idea to just tune into this and sort of understand what I'm trying to do, and try to not copy, but just sort of understand what code I'm trying to put out. Okay, please write a script to solve the following problem. Assume that matrix A, matrix B, and column vector C are defined as the following. Okay. Then mat1, mat2, mat3, mat4, and vector 5 are defined as the following. Okay. So this is what we are trying to reproduce. So if you notice, there are matrix elements multiplied with each other and they're added, and we're going to try our best to manipulate these arrays, which are defined below here, to sort of copy these operations. Okay, so let's start off with matrix 1. How do we solve matrix 1? Well, let's get it started. Oh, but before I do that, I need to copy and paste the given code. Okay, so I have that here, and let's take a look. So we have, notice how we only have half. Notice how we only have half of this matrix with like we really only have like it looks like there are 1, 2, 3, 4, 5, 6 columns, but in fact these are only 2 columns because all of these columns are being added essentially. And you'll notice that there are A elements and then there's B elements, so that gives you an idea of which 2 elements that we are going to use. And if we look closely, this sort of looks like a matrix multiplication question, right? So that means single asterisk within our code. So let me just label this as answer for Mat 1, and it's generally a good idea to try to separate your questions so that we can look through more fluently, I guess. You guys get the point. Okay, if I recall my array multiplication or my linear algebra, when I multiply an array, I need to make sure that if I have an n by m matrix, and let's just do that so MATLAB doesn't freak out. If I have an n by n matrix, I need to make sure that the right side, or the matrix that I'm multiplying by, also has n. So basically, the amount of columns that your first matrix has to match up with the amount of rows that your second matrix has. So if I have m columns, I also need to have m rows for my second matrix. And then, yeah. I hope you guys can see that. Here. You guys, here, let me just put that here. I will cut a lot of this out. If I don't, then you will be hearing my voice right now. I'm going to try to keep this a lot shorter because I know some of your video lectures are pretty long, and they're just it's hard to pay attention for so long, which is why I'll be like cutting this into pieces so you guys can just like skim over the parts that you just want to look at. Okay, so I said that A and B are being multiplied together, so we go Mat 1 is equal to A, and then we go asterisk because we are doing matrix-wise multiplication, not element by element multiplication, times B, and notice that the default matrix, so the untransposed matrix, the original matrix, already has the dimensions that we need. And if we look at how these operations are going to carry out, B1 is multiplied with this, this B1 is being multiplied with this entire column. B21 is being multiplied with the second column. B31 is being multiplied with the third column of matrix A, and then that's where you get your second column in Mat 1 is when this column vector is getting multiplied with A. But let's just run it to see what we get. Okay, what do we get? Run. Oh, okay, let me just. What in the hell? Okay, there we go. QUIZ01 practice. It also might be just like a good idea to just like, if you guys don't want to pause, you guys can just like go ahead of me and like skip forward to see if you guys are smarter than me. I'm kidding, but it'd just be a good idea to try to keep up with the video, or if not, even be ahead of me. So I'm going to run this. I'm going to see what I get. I need to get a new one. Okay. So notice how our matrix dimensions matches up with our diagram that we have here. So we have 2 column vectors with 4 row vectors. Perfect. Okay. So now let's move on to matrix number 2. So we have sort of the same matrix dimensions, except we have 1 less row to deal with. And I notice that there is adding involved. So we have a 3 by 2. We are adding C. We are adding the C column vector to each column vector within matrix B, right? So you C1 plus B1, C2 plus B2, or plus B21, 3B1 plus C31. And to do that, we need to do indexing in MATLAB. All right, so let's get to our MATLAB editor. We can just put answer for Mat 2. Mat 2 is equal to, okay, So since we are adding each element together, what I would like to do is I would just concatenate these, or just picture me separating these two column vectors, individually adding C to them, to each of them, and then concatenating back together. And the way I'm going to do that is by doing this. So I'm going to do square brackets because I want to concatenate. I want to do B and then index. So we're going to do all our rows with the first column, right? So that's this right here. And then we're going to do, we're going to add that with C, or lowercase c. And then we're going to horizontally concatenate, right? Because we got this right side over here. It's not down below, it's on the right. We're going to horizontally concatenate, and you can either do a comma or a space. Preferably, I do a comma. And you can actually put a space after that if you want. That's just the way I write my code. But you guys can do your way. And then I'm going to do B, all the rows, and then the second column. And then I'm also going to add that to C. There. And then if we look at our command window, we should also get a 3x2 matrix. Yep. Okay, so I've just confirmed that my matrix dimensions align. Great. Now let's move on to the next question. Now let's recreate matrix number, or mat 3. I'm just going to prepare this in advance. Answer for mat 3. And I guess simple code like this, you don't really need to sort of explain what you're doing. I can just sort of see that you're doing matrix multiplication here. I'm just saying, like, if you guys have lots of code, if your code isn't really simplified, and if you guys really need to add extra lines, which is completely fine, by the way, that's how you guys learn, you just might need to explain a little bit further as to what you're doing, because that might, you know, you guys want your grades back sooner, so we need to mark faster if that's going to be the case. Yeah, let's go into matrix number 3. So I'm noticing that, let's see, notice how there's only 3 rows, by the way. So the dimensions of this matrix is 3 rows by 3 columns, because these two are being added, or these products are being added. So this should, in the end, should give you a 3x3 matrix. And let's think of how to get to that point. So as I'm analyzing this matrix, I can already tell that only parts of matrix A is being used, because I have A11, A12, A13, A23, and I also have A21, A22, and like I said before, A23 being used in this. So right off the bat, I can tell, because I can't see any of these. I wish I had a pencil that I can draw, but hopefully you guys can see my cursor. I'm just noticing that I'm not seeing any of these elements being used in mat number 3. So that already gives me an indication that only half of matrix A from the top end is actually being used. And then we have B11, B21, B31, B12, B22, and B32 being used. So to me, that looks like the entire matrix B is going to be used in this operation. Okay. This looks like, to me, a transposed version of half of matrix A. Or no, sorry, not even transposed, sorry. Just matrix B multiplied with half of matrix A, because notice how we have 3 rows with 2 columns. These 2 columns actually match up with the 2 rows that we have for matrix A, or the bottom half that we're going to remove soon. And there's 3 column vectors, which indicates to me that we are also going to repeat the multiplication process like 2 other times, here and here. Okay, so how we do that, let's go here. It's for B, so mat3, and I'm going to use my sort of, that is your instructor messaging me. I'm going to take half of matrix A, so, or actually let's make a copy of matrix A. So temporary A, I'll call it, will be A, and then we'll go half of the rows and all columns, and that will be half of our matrix A. And we're going to use this temporary version of matrix A to do this operation. So we're going to do B times or asterisk temporary A, and I'm going to look at the dimensions that we produce. We have a unrecognized function or variable B8, right? B. Okay, let's see what we get. We get a 3x3 matrix, and that seems to align with our answer right here. And notice how there is a column vector of A1, meaning that we have just taken all of A1 and we multiplied it with the first column vector, and then we took A21 and we multiplied it with the second column vector, and that is evidently clear here. Where we have all of A11, or sorry, we have all of A11, and then we have all of A12, and then the elements of matrix B are just sort of being repeated 3 times. All right, next question. Matrix number 4. Vector 5. Okay, answer 4. Mat 4. Cool. So for matrix 4, seems pretty simple to me. So we have all of our elements from matrix B, and then all of our elements are going to be multiplied with sort of a, or we're gonna, yeah, each element of matrix B is being multiplied with a different element from column vector C, and you'll notice that column vector C is being repeated twice. So you have sort of the product of each column vector multiplied together, except one is repeated twice, and that is the key information when writing your code for this question. So how do you solve this question? Well, like I was saying verbally, notice how there are 2 column vectors of column vector C. I'm going to make a matrix, or a 3x2 matrix of column vector C, and then I'm going to do element-wise operation on matrix B, and that will cause both of these matrices to have an element-wise, element-by-element basis multiplication. And in MATLAB, the way we do that is we do a dot in front of any mathematical operation that we have. So that right there is how you do element-by-element basis multiplication. And for any element-by-element basis multiplication that you do, it's a general rule of thumb to have the dimensions lined up. There are a few special cases where you don't have to have them necessarily lined up, but there are a few rules to that. But when you guys are doing your quiz, it's good to have like if you're doing a question like this, it'd just be a generally smart idea to have your dimensions lined up before you do element by element multiplication. So what did I say earlier? I was going to create a temporary version of column vector C. I'm going to take C and I'm going to concatenate it vertically so I can make a 3x2. And then I'm going to make matrix 4 by multiplying B, and then element by element basis operation, right, dot, you have a dot right here, times this matrix version of column vector C. And let's check our code. What do we have? We have a, oh, I should probably suppress that just so you guys can see better. Don't really need to see that. Don't really need to see that. Let's look at our command line. We have a 3x2 matrix, which is also what we have here, and that's how I know that my code is on the right track. I won't actually know until I submit it, but I can tell you right now that I know that I'm right. Okay, so let's go into vector 5, answer for vector 5. Now I'm noticing immediately my initial thought, I thought this was a 2x3 matrix, but that's clearly not the case if all the elements are going to be added. So what this actually is a 2x1 column vector, and also hence the name vector, by the way. That's also how you can tell if you know your guess is correct. So I'm noticing that C1 is being repeated for every row. So you have C1, C1, C2, C2, C3, C3. So that gives me the impression that there is what do you call it? Matrix-wise or vector multiplication being involved. So what I can say is B to me looks like a transposed version multiplied by regular old column vector C here, because the elements are being repeated for every column for C, and every element of B exists. However, if you noticed, B1 is still at the top, however, B12 is at the bottom and just transposed. So I think just from looking at this, I can tell that a transposed version of B is being multiplied with vector C. And let's check if I'm correct. So we take vector 5, that is equal to B. And if you guys don't know how to transpose yet, there's actually two ways you can do it when you're using your simple script editor. Or, oops, sorry. When you're using your script editor. God, so bad at technology. Okay. So there's the transpose function. Transpose, and then inside the brackets here you would put your matrix that you're trying to transpose, so that'd just be vector 5, or no, not vector 5, sorry, B. Or you can just do simply B with an apostrophe, and that will transpose the elements within your array. So B transposed times column vector C. Okay. And if I'm correct, I should get a 1x2 column vector, I believe. Yes. So if we look at our command window, we have a 1x2 column vector. Great. So this is the part where you guys sort of need to cross your fingers and hope that you got the right answer. Partly kidding, because like if you know what you're doing, then you'll know that you'll get the right answer. I can tell that I'm right because it looks like my hypotheses are correct. All my operations are correct to me. All my dimensions line up. I have no errors. And another thing to know is that if your code has an error, then the other questions that depend on the previous question will also be wrong, because MATLAB will just stop to the point where the error is, and it just won't run the rest of your script, and then it'll look like the other questions that were on the quiz, it looks like you got it wrong, when maybe you got your process right. But don't worry, you will get part marks for this. So I'm going to take this. I'm going to take this and I'm going to submit it to MATLAB Grader, and I'm going to see what I get. Submit. Perfect, 100%. Great. So this right here, matrix operation, I'll put a, I guess a video mark at this point as to where this problem ends, and will be highlighted as one of the questions that you should probably review again when you study for your quiz. The next question that we're going to cover is we're going to review creating and modifying arrays from tutorial 2. Let's take a look at that. Is it this one? Yes, okay, this one. Or no, sorry. Okay, I'm going to cut that part out. We're going to review basic array manipulation from this. And you can actually do creating and manipulating vector arrays as well if you'd like, because that is also strongly correlated to some of your questions on your quiz. And if I'm being honest, the level of difficulty is a little bit harder than some of the tutorial and homework questions. These are a little bit more basic and try to get you to understand how to use indexing. But everything you learn in your tutorials and your homework will be completely transferable into your quiz. So if you study this enough and you practice well enough, you should be able to do quiz 1 just fine. And I'll only be doing part of these because this is like there's a lot of questions. But I think I'll just cover the ones that look the most difficult, and judging from what I'm seeing here, most students are getting, or at least leaving, these questions wrong. Hopefully this review will fix that. So let's get it started, shall we? And since I don't really need these for my own sake, I'm just going to delete what I have here, so I can do this problem. For your case, however, I recommend that you just open a new window and then start writing your code for a different question. But for the sake of this video, I'm just going to keep using the same editor window because I don't want to keep saving, if I'm being honest. Okay, hello everyone. So I had to break my video into 2 sections because as I was editing the first video that I recorded, I realized how long it was. And my computer is now making it easier for me to do this in one take. So forgive me for all the cuts, but here is the here's another problem that I wanted to cover in this review video. I'll give you guys a giant hint. Pressure calculation is probably one of the most similar questions in your homework / practice tutorial, whatever, to your actual quiz. So yeah, without further ado, let's just get into it. So I'm going to open up my MATLAB. There we go. Let us just split half and half. Okay, now let's actually read the question. Press 1, press 2, and press 3 contain pressure data from, contain pressure data that are collected from stations 1, 2, and 3 at 1-hour intervals starting from 6 a.m. and ending at 11 p.m. And here are the here's the syntax for this question. Press 1 has a bunch of random variables from 10 to 3, and then it's got 18 measurements because going from 6 a.m. to 11 a.m. at 1-hour intervals is exactly 18 of those intervals. Yes. Oh, actually, sorry. I'm on the wrong pressure calculation question. We need to go to your homework 2 problem because that one is actually a little bit more harder to do. And I think that will be more beneficial to do for your studying. Advanced pressure calculation. Here we go. Now we're on the right one. Let's go on the learner preview. Why not? Okay. So Same question. It's just instead of having just one day at which these stations record data, you have station 1, which recorded all the way, which recorded from 6 a.m. to 11 p.m. Consistently for 10 days, and that's what this column section here is. So you got your rows, and then you have your columns, and then if you think about it this way, I'm going to whip out MS Paint so you guys can see. There we go. I'm going to make my matrix. So if we have an 18 by 10 matrix, I'm not actually going to fully draw it out, but I'll give you guys an understanding of how this matrix actually looks like. Oops, redo. Let's make a line. So from here, no, let's just draw actually. So from here to here, here to here, here to here. So let's pretend that this station only took only measured pressure at, like, let's say 11 a.m. to 12 a.m. So you'd have 11 a.m. here, you have 12 a.m. here, or sorry, 12 p.m. here, and then you have your days here. So if you look at this really bad matrix that I made here, you have, let's call this station 1 data. The press 1 matrix that you see here really looks like this. Let's say we're trying to analyze only the first 2 hour intervals, so 11 a.m. and 12 a.m. You have station 1, which recorded a pressure value here on day 1 at 11 a.m. and then you have the same station recorded at 11 a.m. again, except at station 2. And then you have here, which is still 11 a.m. but just at day 3, and then so on and so forth. And then the next row you have 12 a.m. data except on the first day, and then you have 12 a.m. data except on the second day, and then so on and so forth. And this data press matrix that you see here, all that does is it just concatenates it concatenates 3 of these. Let me just select. It will concatenate 3 of these matrices horizontally. So then you have an extra long matrix where every, I believe, 10 columns is, where every 10 columns and 18 rows is exactly is the data from 1 station. Great. So now that I got that out of the way, let's actually start solving some of these problems. We'll call this A. Okay, so create a 1 by 10 row vector called data press. Data press 8 a.m. station 3. And then that will equal the data collected at 8 a.m. of all 10 days from station 3 in order. Okay, so what this essentially means is if we look at our data press matrix we have here, this is an 18 by 30 row vector. So the actual day in which, or sorry, the actual column in which station 3 data is present is on the 21st column, just because of how MATLAB indexes things, right? So if you go from station, sorry, data, let's just start indexing first actually. Data press, oops, variable. So if you go data press and you want data from 8 a.m., right? And 8 a.m. is actually the third, yes, it is the 3rd row, right? Because your first column, or your first row, excuse me, starts on the 1st row. So then that means if you count up, if you could just do 1 plus 2 rows, you have 8 a.m. Or sorry, if you start at 6 a.m. and that's your 1st row, that means 8 a.m. will be your 3rd row. Hope that makes sense. But yeah, and then this whole deal with containing data collected from all 10 days from station 3, all that really means is we're collecting data from rows 21 to 30. And you might be wondering as to why it's not 20. Well, 20 is actually the 10th day in which press 2 data, or sorry, the 20th column is actually day 10 for the second station in the data press matrix. And if that's still confusing to you, just keep in mind that MATLAB indexing doesn't start at 0. It starts at 1. So if you want to make a 1 by 10 row vector, you don't say 0:10. Like let's say if I want to make a 1 by 10 row vector, you don't say 0 to 10. MATLAB simply just will not let you do that. You need to start at 1 all the way to 10, right? So it's the same thing. In this case right here, you just have 21 all the way to 30, and then we have a 1 by 10 row vector. I hope that makes sense. Great. Next question, let's go to B. Let's go on to question C. Create a 1 by 3 row vector called data press 9 a.m. second. Data press 9 a.m. second, which contains the data collected at 9 a.m. of the second day from all stations in order. Cool. So if we look at our data press matrix, data press, 9 a.m. would simply just be plus 1 of 8 a.m., so it would just be 4. So after we go 4, then we want to make a vector for our column because we are individually picking out these columns. And the way I'm going to do this is I'm going to start at 2, right? Because we want the second day of the first station, and then we want to go in increasing order by 10. So I'm going to 2:10, and then I'm going to colon again, and then I'm going to stop at the 22nd, right? Because that would also be the second day of the third station. So what I have here is the exact same thing as this right here, 10, 12, and 22, right? You get the exact same answer if you wrote it this way, or if you wrote it my way earlier, like this. Exact same vector. Okay, and I just realized that I forgot to run some of these. Let's just check our command window to see if we get any errors. Oh, there are errors. Okay, cool. Unrecognized function or variable data press. Ah, right, because I forgot to copy and paste the given data. Important stuff. So there we go. Let's run it again. Wow, that is delayed. Okay. So if you look at our question we have here, for A we need a 1 by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I have. 1 by 18. I'm just going to eyeball that, and I'm going to say that looks like 18. And then a 1 by 3 row vector, which is what we have here. So from my sense of judgment, I think what we have from questions A to C is completely correct. Let's continue with this question. Let's go to D. Create a 3 by 10 matrix called data press 9 a.m., which contains the data collected at 9 a.m. of all 10 days from all stations. Cool. Okay, data press 9 a.m., which contains the data collected at 9 a.m. of all 10 days from all stations. So the way this is broken up, let's put out the MS Paint again. The way this is broken up is that every row essentially just represents one station, I guess, because we're only measuring data from 9 a.m. We're only measuring data from 9 a.m. and we are essentially taking the 10 days from each station, and we're just concatenating them vertically, and you'll see what I mean. I'm going to draw some more lines. Okay, let's pretend this right here is 9 a.m. of the matrix. Okay, and let's pretend that the vertical columns represent the days. So we have 1, 2, 3, 4, 5, 6, 7. We'll call this one 8. Let's just say that, for the sake of this example, let's just say that station 1 only records data every 2 days. Station 2 only records data every 2 days. And then station 3 records data every 2 days as well. Right? Sorry, forgive me. MS Paint is not that easy to use. Oops. Cool. And if we are trying to visualize how to do this question, if we are containing the, if we are trying to concatenate 3 vectors vertically, this is how MATLAB would do it. So we are going to take the first 10 days, but in this small example, this would just be 2 days. So we are taking the first 2 days of station 1. We are taking the first 2 days of station 1, which is this, at 9 a.m. And that will be the first row of our matrix. And then we are going to take the station 2 data at 9 a.m. At each day, which would just be 2 in this example, and then we concatenate that vertically again. And then we're going to take station 3 data from 9 a.m., which would just be this section right here, and then we concatenate that vertically as well. Now in this example, like I mentioned earlier, only has 2 days, but in your example you have 10. However, the process is still the exact same. So if I'm going to do this how I mentioned it to you guys, I'm going to use square brackets for this question, and I'm going to directly index data press this way. So I'm going to go data press, and then I want 9 a.m., which would just be the 9th row. Or, sorry, 9 a.m., which would be the 4th row, excuse me. And then we want station 1 data, which would just be columns 1 to 10. Columns 1 to 10. From all 10 days. Yep, okay, cool. And then I want, okay, so I'm going to concatenate this vertically, keep that in mind. Then I want the second station data, which would just be almost the same thing. We have a 4, except this time we're going to add 10 to our row vector, so we're just going to get 11 all the way to 20. And then I concatenate that vertically, and I'll go data press, and then we want our third station data, and then we're going to go 4th row, and then add 10, so we're going to go 21 to 30 days, and that will be our third station data. I'm going to run it just to see if I get any errors. And we have a 3 by 10 matrix. Cool. That looks right to me. Let's go on to E. Create a 3 by 18 matrix called datapress 5th, which contains the data collecting of the whole day from the 5th day from all stations. Alright, cool. So we can name our variable data press 5th, and that equals the 5th day from all stations. From all stations and the whole day. So that means we're going to use all of our 18 rows that we have from 6 a.m. to 11 p.m. So let's go to data press. There we go, data press. And I'm also going to concatenate these. How am I going to concatenate these? Creating a 3x18 matrix called data press fifth, which contains the whole data from the fifth. Oh, okay, so I think we are going to transpose our matrix here. For instance, the third row of data press fifth contains measurement of the whole day of the fifth day from station 3. Okay, so all right. So I'm going to do this a very unique and special way. I'm going to use indexes that don't exist yet, and then I'll fill them with actual data. So the way you do that is you do row 1, because I'm going to start off at row 1 for this question. So you go row 1, and then we go all 18 columns equals data press, right? Data press, and then we're going to do the entire day. We're going to do the entire day because we want all 18 measurements, and then we want the fifth day. So we want the fifth column from station 1. But just keep in mind that these dimensions are actually 18 by 1. However, the left side of our matrix, we are actually referring to a vector that is 1 by 18. So we just have our columns and vectors switched, and you guys know how to do that. I showed you guys previously. All you need to do is add an apostrophe, and then I'm going to do that for the rest of the rows for data press fifth, and we're going to mention the second column, or the second rows, all columns equals data press, and then we're going to mention the second station data. So we're going to add 10, we're going to go 15, and we're going to transpose that. Right, data press fifth. We go third, all columns, data press 1 to 15. Okay, and just as an FYI, on your quiz, we will have like examples that will tell you like what we're trying to do. We don't want you to guess stuff, so we think we will tell you if like what the rows mean. So if you don't know if time will be the row or if time will be the column, we will tell you as an example, row 1 is a representation of all the measurements taken from day 1 or something. Like we'll tell you, and we'll make sure that you guys understand. Yes, so let's run it. I want to see what data press actually looks like. I'm going to press these two. So we have a 3 by 18 row vector, I want to say. Yes, we have a 3 by 18 row vector. Cool. Yeah, so this strategy that I used, I indexed non-existent array dimensions at first, or array indexes, I should say. I referenced non-existent array dimensions, and then I filled it with data that actually does exist with the exact same array dimensions. So that is another strategy you guys can use on your quiz. A, B, C, D, E, F. Let's go to F. So you realize that data from station 2 is abnormally low, and should be corrected by adding 10, and then create data press new, which is copied from data press. Okay, which is copied from data press. Then please add 10 to all the measurements from station 2 and data press new. Cool. What? Why is that there? Data force I don't know why this part is within question F. I think it meant to be in question G, but that doesn't matter. So for question F, what we want to do is we want to index all of station 2 data, which would just be all the rows and then columns 11 to 20. So we want to index that in our data press new, and then we just want to add 10 to that, and I'll show you guys how to do that. So we'll go data press new, and then we're going to index all the rows and days 11 to 20, because that is our station 2 data. And we're going to actually copy and paste this on the other side and then add 10 to it. So all this line means right here is we're just saying, okay, so I'm indexing station 2 data. I want you to take station 2 data, and then on the other side of the equal sign, I'm saying I want you to take the station 2 data and I want to add 10 to it. And that sounds a bit repetitive, but you need to tell MATLAB specific things like all the time, because if I just did data press new is equal to colon, comma 11, colon 20, and I did it plus 10, we will get an error. Oh, did that work actually? No, it didn't. Okay, cool. So if you notice in this example, what really happened is we just replaced all of these elements within data press new, and we placed it with 10. So obviously that doesn't work. We need to incorporate the same line we included on the left-hand side, and we need to put that on the right-hand side of our equal sign, and that way we are telling MATLAB, take the same values that I just indexed and add 10 to them. That's all this line means. Cool. Now we got that out of the way. Command window. Okay, there. And you will notice that we have actual correct values now. Cool. So that was question F. Now let's go on to question G. If the cross-sectional areas of the devices at all stations are constant and given as area device const, please convert the data press. Please convert data pressure data, and then in quotations data pressed new to force data, and assign the resulting matrix to data force constant, respectively. In other words, that just means, where is that? Did he say data force constant? Data force constant. Okay, so we're just assuming that all the stations were recording pressure in the exact same cross-sectional area. So I'm just going to put data, what is the variable name for this? What is the variable name for this? Pressure data, data press new to force data, and assign the resulting matrix to data force constant. Data, okay, so our variable will be data force constant. Okay. And what we're going to do is we're just going to take data press new. And we're going to multiply it by the area device constant. Area device constant, because it's only one number, so we're not actually doing element by element basis, so this is just simple linear algebra. And that answers that question. So that's question G. Let's move on to H. So for H, if the cross-sectional areas of devices at stations are different and their areas are given as area devices, Please convert the pressure data and data press new to force data and assign the resulting matrix to data force diff. Data force diff is equal to, I'll show you what it's equal to. So what I'm going to do for this question is I'm just going to essentially just index data force new. So we're going to take our new pressure data in which we added 10 to right here, and I'm just going to directly index the section that I want, and then I will multiply it with the first element of area devices. Notice how this is a 3x1 column vector. All this question is really saying is area devices has 3 separate cross sections. Each cross section corresponds to the station number. So if you are trying to convert station 1 data to a force, you would just multiply by the first element in area devices. I'll show you what I mean by that. And the way I have to do this code, the way I want to do it is, because I'm only indexing parts of a matrix, I need to essentially create, right? I need to join. I'm essentially decomposing the new data press matrix into smaller matrices, and then multiplying it by a constant to each of them with their respective constants, and then I'm gluing them back together. And the way I have to do that is through a horizontal concatenation. And let me show you what I mean by that. So I'm going to do data press, and then I want all times, and then I just want station 1 data, so that would just be from 1 to 10. And then I'm going to multiply it by area devices, and then we said that the first cross-sectional area corresponds to the first station. So area devices 1, cool. And then concatenate it vertically, or sorry, horizontally. Data press, and then I'm just going to repeat the same process except for the other stations. Data press, and then 11 to 20 since we're doing station 2 times area. Sorry, if your code gets too long, there's this cool, simple MATLAB function. What you can do is just 3 dots, and then you can press enter, and then you can continue your code afterward. So I'm actually going to do that here, so it's less confusing. So I left off here. So data press. Oh, and I want to make sure that I'm using data press new, not the old one. So data press new, and then we're going to reference the second station, 11 to 20 times area devices 2, and then we're going to go for our third station, data press new, all rows, and then columns 21 to 30. And then we're going to multiply it by area devices. Area devices. And then we're going to go to the third element. And I'm going to end that concatenation there. I'm going to run this because longer code tends to screw up a lot more, just through my experience. And we have a 30 or 18 by 30 matrix, which is I think what we want. Yeah, we want 18 by 30 matrix. That looks right to me. Let's go on to the next question, which is I. Okay. Let's see what I says. You still do not trust the data from station 2. Please create data force new, which is copied from data force constant. Then remove all measurements from station 2 data. Note that the size of station force new is 18 by 20, right? And that's just because we are removing columns 11 to 20. So when we remove that, we're obviously going to reduce the size of our matrix. So the first step into this question is to just make the variable, so data force new. We're going to go data force new, and then we're going to copy it from data force constant, and I'm going to suppress that because I don't really need to see in my command window. Then remove all measurements from station 2 in data force new. Okay. Data force. Oh wait, that doesn't make sense to me. Data force new, just copy from data. Oh, it's data force new. I thought it was data press new. Okay, cool. So data press new, and then we're going to index the second station data, which would just be what I mentioned earlier, all rows, columns 11 to 20, and then the way you delete things in MATLAB is you simply assign an empty vector to it, which is just a empty square bracket, and if we press run, we should notice that we have, oh, that looks wrong to me. Or is that right? Yeah, that is wrong. So we're supposed to have an 18 by 20, and we have, oh, it's right, because it's just a giant. It's just a giant. Alright, okay. So we do have a 18 by 20 matrix. It's just, I was just reading this part, that's why it didn't make sense to me. Cool. I'm going to say that my code is right, based off of what I saw in my command window. I think I'm pretty confident enough to just copy and paste it into MATLAB Grader. I'm going to submit it. Cross my heart I get everything right, please. Oh my lord. Okay. Let's see where we goofed. Data press second station 2. So variable data press second must be size 1 to 18. It is currently the size of 18 to 1. Alright, let's see if we misread that or the code is wrong. So that is B, create an 1 by 18 row vector. Right, okay, so I am wrong. I am wrong, okay. Hello everyone, so after just realizing that I got 2 questions wrong on the MATLAB, the simple fix that I just have to do to fix this problem is add an apostrophe to transpose a 18 by 1 vector to a 1 by 18. And then the second question that I got wrong was question number, or question letter, was it D? I believe it was D. I want to say it was D. Which contains the extra. Or no, sorry, it was question F. E, sorry. What is wrong with me? It was question E. Yeah. So the mistake that I made was that for every 5 days, right? So every 5 days from every station, that means column number 5 will be the 5th day of station 1. Column number 15 will be the 5th day for station 2. And I accidentally wrote 15 again instead of 25, so I'm just going to change that to a 25. And that 25 will be the 3rd day of, that will be the 3rd day of, or sorry, the 5th day of station 3. So I'm just going to put this code back into MATLAB Grader just to show you that that was the mistake that I made. And I'll get every other question right, but I'm just going to show you that I'll get B and E right just for this section, because you guys saw that I got the other stuff right already. So yeah, as you can see, these two are right now. So yeah, I hope that didn't confuse you guys. I hope some of the video edits that I made cleared up the confusion before the errors showed up on MATLAB Grader. Thanks.